All right, this is Advanced Math, Unit 5, Morning Review, starting with number 1, true or false? Is 1 minus secant squared equal to tangent squared? It is false. What is 1 minus secant squared equal to?
Negative tangent.
Plus tangent.
Okay. 1 minus secant squared is negative tangent squared. Does everybody see that? 1 minus secant squared is not positive tangent, it is negative tangent squared. All right, would anybody like to see that rearranged like by hand?
No.
We're good?
Yeah.
Awesome. Okay, so this was false, yes?
Yeah.
Okay, moving on, number 2. My mechanical pencil, my pink one.
Give it back, Chauncey.
Aaron, I may have to.
Okay, I'm sorry.
No, I did not. Okay, we're going to continue. Here it is. Number 2. Okay, guys, the biggest mistake kids make here is they treat this here as the cofunctions, the complementary cofunctions. This is not a cofunction. This is the even odd. This is where it either kicks to the front or absorbs. So I am going to show you really quick. These are the notes from that day, from that lesson. I added these here in pencil for my last class because they were kind of struggling with them. But what is the only one that absorbs the negative?
The cosine.
Cosine and its reciprocal, which is secant. Sine, tangent, cosecant, cotangent kicks it to the curve, to the front.
That's what I always think.
Got it?
Kick it to the curve.
Okay, so, but keep in mind, cosecant will stay cosecant. So I'm going to write that down. Negative theta is going to become theta, and what happens with the negative? Kicks it to the front or disappears? Why? Because cosecant is the reciprocal of sine,
Sine, sorry.
and sine does not absorb, it kicks it to the front. So true or false?
False.
False. All right, next one. Anybody know how to simplify the left side? What we can do? What should we do? GCF if it was an addition sign. But since it's multiplication, yes. Okay, she said change everything to sine and cosine. Okay, so can I rearrange things and put the 8 times 2 together?
Yes.
And then cosine x times 1 over
Cosine.
cosine x. And what ends up happening?
They cancel out.
Leaving behind 16 to 16 equals 16.
Yes.
True. Make sense? Okay. Simplify. I'm hoping everyone can do some of the rearranging in their head. Looking at our orange poster, is there any way to get cosine squared minus 1?
Yeah.
Is it one step or multiple steps?
Multiple.
So if I minus the 1 and scooch that to the other side, is it equal positive or negative sine squared?
Negative.
Okay, so what's the answer for number 4?
Negative sine squared.
Negative sine squared. Does anybody want to see the work for that one worked out?
No.
No. Okay. Negative sine squared. We're all good?
Yes.
Okay. Next one. This has the complementary cofunction and the even odd functions. I'm going to work with the even odd first. What is secant? Bless you. It's okay. What is secant the reciprocal of?
Cosine.
And what does cosine do with the negative? Absorb. So it's gone. Secant will stay secant. Okay. Cosecant's the reciprocal of what?
Sine.
And what does sine do?
Kicks it to the front.
All right, so negative cosecant x. All right, secant stays secant, cosecant stays cosecant. Both the negatives become x's. One absorbs, one kicks to the front.
Yes.
Times 1 over. Now, this next piece What kind of function is this? Is
The
this the even odd or the complementary cofunctions? The complementary cofunctions. All right, what cosine becomes what?
X.
Okay, you're a step ahead of me. Pi over 2 minus x does become x. You guys okay with that part?
Yes.
And then cosine becomes sine. Why? Because we did what with the word cosine? Took off the word co, and we're left with the word sine.
Why do you take off the co? Complement.
Because that's the co-function part. If it didn't have a word co, like say secant, you would add the co and become cosecant. Yes.
If it was sine pi over 2 minus x, would it become cosine?
X. Yes, it would. So that is right here. All right. Guys, you add the word co or take away the word co, depending on what it says. Okay, so any thoughts on what to do next? I'm trying to simplify.
You turn everything to sine and cosine.
Turn everything to sine and cosine. Okay, secant becomes what? 1 over
1 over cosine.
cosine. And then negative 1 over
Sine.
sine x times 1 over sine x. All right.
Then you multiply.
Keep changing.
Okay, keep change flip. Is that what this is ASC? Yes.
Since it's a multiplication, I should cross out the sine x and the sine x.
Yes.
Oh, wait, can you?
You can. Not many kids visualize it that way, but yes.
Oh, that's what I've always found it never.
Okay. Guys, there's multiple ways of doing this. I heard keep, change, flip, multiply by the reciprocal from this side. My last class said, oh, on this side, multiply everything by sine, cosine. Who asked about reducing? Was that Sean? Sean said, I'm assuming, Sean, did you say something like this, like cross-reduce those out completely? Yes. Someone in my last class said, can I change 1 over sine to cosecant and then reduce? All of those work.
But how is that? Where does the 1 come from?
This, it's anything, it can be written as over 1. I
Yeah,
just,
but the whole fraction. It's like 1 over, and then like if you look at the original one,
which piece?
like the top, like it's 1 over, and then that turns into sine x.
Uh-huh.
How can you have like
I can make it a fraction. I can make a fraction over a fraction. And I can make that over a fraction. I mean, I could do it all.
okay.
Yeah. Okay, so I'm going to do it the way we've always done it in class. I'm going to work with this side first and multiply by the reciprocal. 1 over cosine x times negative what? Never sine x over 1, which is negative sine x over cosine x. Do you guys agree that's what this piece here simplifies to? Times 1 over sine x, what reduces?
The sine.
Leaving behind negative 1 over cosine. And what's negative 1 over cosine x?
Negative secant.
Negative secant x. Don't leave it as negative 1 over cosine. Negative secant. Now, if Sean had reduced over here, would we still end up with negative secant? Yes. The kid who said, can I change 1 over sine to cosecant and reduce, would we still end up with negative secant? Yes. All right. Any questions? Okay. Number 6. Simplifying. Any suggestions? And there is more than one right way to do it. Yes.
Make the bottom into the identity.
Make the bottom into an identity. Do you guys agree with her?
Yes.
1 minus cosecant squared. That is one that requires an extra step.
Negative cotangent.
Negative cotangent. Can everybody visualize that extra step that it's negative cotangent?
Yes.
Okay, so I have positive cotangent squared over
Negative cotangent squared.
negative cotangent squared,
And would that just be negative 1?
and that would just be negative 1. Good job. Everybody ready? Number 7, verify. Verify means prove. That's where you pick a side and stick with that side.
Left.
Left side is what I hear. Left side?
Oh, yeah.
Okay, guys, remember, because a lot of you, not a lot, some of you did not do this on the quiz, and I will mark it wrong on test day. Bubble in the side that you are working with. Don't just pick a side and go. Bubble in that side. Did I already tell you guys? Yes, I did. Never mind. All right. Pick the side. What do we do? Yes.
You can do sine x and cosecant, and like make them into sine and cosine, and they cancel out the signs, leaving just one.
Good job. She said change everything here to sine and cosine, and that leaves just one. Does everybody agree with her?
Yes.
Okay. What else? Plus.
Then you can turn, plus sine squared x. Over plus sine squared x.
Okay.
You can just turn into tan.
Okay, so now Giselle's telling me to change this to tangent. Why is that a good idea?
Because it's an identity which equals secant squared x.
There you go. Because 1 plus tangent squared is an identity. 1 plus tangent squared is what? And secant squared equals secant squared. That's what we're trying to prove. Don't forget, you box in. That doesn't mean that's your answer. That means you are done. And guys, I do check work, so please don't just write junk in there because that just irritates me when I'm grading. And be neat and be clean, and if you make a mess, you better be working in pencil to erase your mess, because I don't want to see junk everywhere and arrows, and it's just, this is a hard test to grade. Please don't make it any harder. Questions? All right. Moving on to number 8. Same thing. We are still proving. Pick a side. Left side. Anybody? I'm going to stop before I go any further. Anybody figure like I still not sure what side to pick?
So this one is because it has a parentheses and squared.
Okay, she said this one she would pick the left because it's quantity squared, which means you would do what with it? Write it twice in FOIL. That's a very good observation. You guys didn't think of that. Take that from her, put it in your head. I had some kids in my morning class say, oh, I would pick the right side and factor difference of 2 squares. Go for it, but does factoring difference of 2 squares get you closer to this?
No.
No. All right, so go for it. Write that twice and do your double distribution. Sine x minus cosecant x times sine x minus. That sign in the middle does stay the same. Double distribute. What sine times sine?
Sine squared x.
And then I get minus sine cosecant minus sine cosecant.
Minus 2 sine x cosine squared x.
Cosecant x.
Cosecant.
All right, do you guys agree with her? Minus 2 sine x cosecant x. Yes or no?
Yes.
And at the very end,
Cosecant squared x.
you guys are awesome. Cosecant squared x. Okay. Now, how you approach the next step really just depends on how your brain processes things. Okay, so look at what you have. Look at what you're trying to get, and think about your identities.
Can you take out something?
Can I factor anything out? I cannot, because there's no like term. They do not all have a sine squared, and they do not all have a cosecant squared. But good thought process.
You could find an identity.
Okay, so that's one option. We
Oh.
can rearrange, we can try to find an identity, we can do some changing. Any thoughts?
This is gonna be so hard to follow.
We're going to talk about how to get that on paper in just a little bit. Yes.
Get the middle just turn to -2.
Okay. He said, does the middle just change to -2? Does everybody agree with him on that one? Yeah, because what sine times cosecant? Does that reduce to 1?
No, 1.
Yep, so I have sine squared minus 2. And then plus cosecant squared. Does everybody see how he did that?
Yeah.
All right. We're now at least a little bit closer to what we're trying to get and trying to manipulate things.
Okay.
You can, I don't know.
Come on, guys. Test question. What do you do next?
Can you just
Can you
make
turn
it
everything
sine
to
squared
sine?
minus 1
What?
plus cosecant squared?
Okay.
Yes.
How
Okay.
double bubble?
All
Oh,
right.
wait,
All right.
are you gonna
Okay.
make it?
Yes, and what did you say? You said something. You said change the.
Oh, I.
That is one.
Okay, what did you say?
Are you changing them like the sine squared x to like what is it?
1 minus.
Yeah.
Okay.
So you're just using this.
I just split the 2 in half so that the sine squared and the cosecant squared could each have a 1.
Okay, that's what you said.
What?
All right. Both methods work, and it really just depends on how your brain processes things. So I'm going to show you the both ways, and you guys are going to decide, well, I'd most likely choose this way, I'd most likely choose that way. Okay, so here we go. Sine squared x minus 2 plus cosecant squared x, and then I'm going to write it again, sine squared x minus 2 plus cosecant squared x. All right. The two of you said split up that -1 to sine squared x minus 1 plus cosecant squared x minus 1. Would you guys agree that -1 and -1 make the -2 in the middle? And sine squared still there and cosecant still there, yes or no?
Wait, you can do that?
Yes. Okay, so what does sine squared minus 1 become? A negative cosine squared. I'm glad you observed that it's negative because it's an extra rearranged step. Negative cosine squared x plus, what is cosecant squared minus 1? Positive cotangent squared. And what we're trying to prove is that the the thing?
Oh, yeah.
Cotangent squared x
No.
Oh, we get to
minus, no, we just rearrange it.
Oh.
Do you agree?
Yeah.
Equals, and then cotangent squared x minus cosine squared x. Whoa, that's messy. Okay, did it work?
Yes.
Okay, so I'm going to show you the other way. Now, in my morning class, I had kids give the same as you guys, both suggestions. Some kids said, I'm going to change sine squared. What does sine squared change to? Minus 2, and then cosecant squared changes to what? 1 plus cotangent squared x. I don't need those parentheses. I just put them there so you can see that this is the sine squared and this is the cosecant squared. Do you see that?
Yes.
Okay, so what's going to happen when I combine like terms?
It's all gonna.
Let's see. I have 1 plus 1. What is 1 plus 1?
2.
And then -2. What happens?
0. So they just cancel out.
So positive cotangent squared x and then negative cosine squared x, is that what we were trying to prove?
Yeah.
How many of you feel like the way I just did is most likely the way you would tack it on the test? And whatever works for you, how many of you would look at it and know to split that -2 to a -1, -1?
What if it's like 3?
Then you would do -1, -1, -1, and then somehow it all work out.
It's 3 different.
Yep. Okay, are we good?
Yes.
Okay, so you choose your method and go with it. All right, write a method down. Did you guys write one down? I'm hoping you did. Anyone care which one I write down?
No.
No?
So we only have this to do, and then we're like working on our review.
Yes, and going over the quiz.
Oh.
Okay. Did you guys all write one of the methods down?
Yes.
Okay. And number 9. Okay. Anybody know what number 9 is? We talked about it. I said I would prepare you for it.
Oh,
Yes.
I know what it is. Oh, it's where you do the opposite of the negative.
The opposite of the negative. What is that called? Conjugate.
How do you know when to use it?
How did you know?
Oh, because you have to cancel that out. Not cancel it out, but do the double thing. I don't know. I don't know how to explain it.
Anybody? How did you recognize it? Okay, this is on the bottom. Do they kind of look the same? But one at the bottom, one's not. One's a minus, one's plus. That's the kind of the frame where you should be in, where they look the same. There's a minus, there's a plus. One's the denominator, one's not. I'm going to pick the left side. And I'm going, don't forget to bubble in. I'm going to multiply by the conjugate. Conjugate you learned last year. It's where everything stays except sign in the middle. I don't know if you had one last year, but if that secant was negative, it would stay negative over here. The only sign that changes is the one in the middle. Okay? Now, what's going to happen when I multiply the numerator by 1?
It's just gonna be the same.
It's going to stay the same. That's the multiplicative identity. Secant x plus tangent x over, and now we're going to double distribute.
That's secant squared x minus tangent squared x.
Okay, how did she get that, guys? She got secant squared x minus tangent squared x.
Because the middle part just cancels out.
Will the middle part cancel out?
Yes.
And then you say it's an identity.
And we see that's an identity,
1.
which is 1. So I have secant x plus tangent x over secant squared minus tangent squared. Is that indeed 1?
Yeah.
So I'm left with secant x plus tangent x. Is that what we're trying to prove? Okay. Questions on that one? Is there one of these, at least one of these for sure on the test? Yes. So if you get to one and you're stuck and you haven't done the conjugate yet and it looks something like this, then that's what you should do. Questions? Okay, number 10, solve.
You add the 4.
Add the 4. She said add the 4. What would you do next?
Divide by 2.
Divide by 2. Add the 4, divide by 2. Go ahead and do that now. Secant x equals
1/2. And it's
equals 2.
1/2.
Yeah.
You're a step ahead of me. Okay, somebody asked something over here. Should we what?
Oh, flip.
Oh, yes. Okay, so you don't write it as 1 over cosine. You just take the reciprocal of both sides. Yes. Mm-hmm.
Because you add 4 divided by 2.
Because you
Yep.
flip it at the end.
Yeah. So we add the 4. Do you see where the 4 is over here? Then you divide both sides by 2. Yeah?
Yeah.
Okay, secant x equals 2, and then you guys said flip, so secant becomes what?
Cosine x.
Cosine x equals,
1/2.
how many places is cosine positive?
60.
And cosine of what angle is 1/2?
60.
60. That's okay. Is 60 one of the answers? Yes, because we're in quadrant 1, so 60 degrees and 300.
Oh, yeah.
Can you call it negative 60? No. According to this, it should be between 0 to 360. Okay. Are we good?
And because there's no number in front, that's why it's only 2 of them.
Correct. Because right here, no number right there. Is that what you're talking about?
Yeah.
Yeah. All right. Questions on that one? None? Ask me a question. Anyone? No question? Okay. What should we do on number 11?
Oh, you can subtract the sine squared x, and then it'd be separate ones, right?
I want to get it equal to 0 so I can factor. Yes.
So you,
So when you subtract the 3 sign, then you can do the guess and check.
The guess and check is correct. Okay, so she said subtract this and then guess and check. Sine squared x. Where should the minus 3 sine x go? The middle or the end?
Middle.
Minus 3 sine x minus 4 equals 0. Okay, substitution, U substitution, or no U substitution? I'm going to use it since I heard a few of you say yes. Now, do you have to use U substitution? How many of you'd rather not? Then don't, just factor as it is, you're good. Okay, I'm going to let U equal sine of x. That's U squared minus 3U minus 4. Double bubble. I will let you guys finish it from there. What do you get?
U minus 4, U plus 1.
Minus 4 plus 1. What does U equal? 4 and negative 1. Am I done?
No.
No.
Plug it back in.
We have to plug it back in. I have sine of x equals 4. And I have sine of x equals, let's do the negative 1. Sine of what value is negative 1?
The 180.
270?
Oh, 270.
Okay. Sine of what angle is 4? Is that on the unit
No,
circle?
you have to do it yourself.
What do we do?
You have to make your own.
Oh,
Make your own picture? And what happens when you have 4 over 1?
Opposite over.
Okay, she said opposite over hypotenuse. So I'd have opposite over hypotenuse. Does that make any kind of sense? No. Does it make sense that the opposite, the leg is bigger than the hypotenuse?
Yes.
No. Do you guys agree? The hypotenuse should be the biggest. So for this one, there's no solution. So the only answer is 270. Do you have to write 270 comma no solution? No. I will see that in your workspace. Guys, another way to think of it is sine by itself. There's no amplitude change. What two numbers does the sine graph oscillate between? 1 and -1, right? Is it ever going to hit 4?
No.
No. No solution. Never going to happen. So 270 is the only solution for that one. Does that make sense?
Yes.
Yes? Okay. Number 12. Thoughts, suggestions?
Bring over the 1.
Bring over the 1 is a good suggestion. So 2 sine squared x minus sine x minus 1 equals 0. Use substitution. And factor.
So 2u plus 1 and u minus 1.
Okay, she said 2u plus 1 and u minus 1. Do you guys all agree with her? Okay, so what two values does u equal? Negative and positive 1. We plug back in. Sine of x equals -1/2. Sine of x equals 1. Can anybody tell just by looking how many answers we're going to end up with?
30.
2 from the -1/2 and 1 from the 1. Let's do the 1 first. Sine of what angle is 1? 90. What two places is sine negative?
The bottom 2.
The bottom 2. And what's my reference angle? Sine of 30.
But that's not one of them.
But 30 is not one of them. Good job. Why is 30 not one of them?
Negative.
Because it's negative. So what are my two answers there? 210 and 330. And which one did we get here that I did not write down yet? 90. Make sense? Yes or no?
Yes.
Oh, I have one.
You printed one off?
I printed one.
All right. Any questions? Okay. I'm going to have you guys try on your own. We're going to do 14 first. I'm going to have you try on your own number 14. It's already equal to 0. I know. We're going to skip it for now. We're going to come back.
Is that supposed to be a squared x? Or
No, that is supposed to be a 2x.
Oh, Lord.
Okay. Are we ready? What did you guys do?
I did greatest common factor.
Okay. Do you guys agree it's a greatest common factor?
Yeah.
I did that, but then I stopped.
Okay. Tell me what you at least did for the greatest common factor.
Cosine 2x.
Cosine 2x and then,
Parentheses 1 plus secant x.
yes?
Yeah.
We're ready for the zero product property?
Yeah.
Cosine 2x equals 0 and 1 plus secant x equals 0. Subtract, what do we get? Secant x equals
Negative.
-1. I'm going to do this one first since it's easier. Take the reciprocal of both sides. Cosine x, what's the reciprocal of -1? -1. How many places is cosine negative? 1? 180. Do you agree that part was easier?
Yeah.
Okay, cosine 2x. This is where I do 2x equals. Now there are two places where, whatever this is, cosine is 0. What two places is cosine 0?
90 and 270.
Okay. Questions before I move on from the 90 and 270?
No.
No? Okay. Yes. right here, I take the reciprocal of both sides, like right here, we did it here. Secant's reciprocal is cosine, 2's reciprocal is 1/2. And it was probably easier to see here because you could see the reciprocal. It's a little harder to see here because the numbers stayed the same. But we did take the reciprocal. It just happened to be the same number. Very good observation and question. Okay, what do I do, guys, because of the 2x? What do I do?
Add 360.
To both of those, correct?
Split it.
And then, okay, so here's my first set. Second, what's 90 plus 360?
450.
450.
Divide by 2.
And then 270 plus 360? 630. Okay, now that's for 2x. If it said 3x, what would I do? I would do one more set. There's the first, there's the second, one more if it had been a 3x. But it's a 2x, so I now divide everything by
2.
even the ones that are smaller than 360, all of them. So x equals 90 divided by 2 is
45.
45. 270 becomes 135.
10. 35 and 225.
225.
And 15.
315. And why would I get this wrong?
180.
180. Good job. Many times kids get all caught up in the big work. They forget that one little answer by itself. Please don't forget it.
I thought you just divided like 450 into 360.
Yeah, that's why I want to make sure, because a lot of kids think that. They're like, oh, the other ones are fine, just divide the big ones. All of them, including the ones that are smaller than 360.
Okay.
The only one that didn't is the 180, because that was a separate problem in its own. Does that make sense?
Yeah.
What was that? No?
Oh, no.
Okay. Next one. 13.
You put everything to one side.
Yes, let's put everything to one side. Are you guys okay with that?
Yes.
2 sine squared x plus cosine x minus 1 equals 0. All right. Right now, can I do my guess and check factors?
No.
No.
You can use the cosine. Only thing I can think of is changing the sine squared x to like a
Wouldn't
Okay, that's what you said as well.
Can't you do 1 times 2?
Can I do 1 times 2?
Because sine squared x. Oh, never mind. It's not squared.
and then it's cosine.
I thought it was squared for a second.
Okay, it's okay. Yes, Sean?
Oh, never mind, it's square, never mind.
Okay. I heard the right answer already. I just want to hear what else you guys have to say.
Okay, so can you just, so for the sine squared and the x and the minus 1, like change that into something else and then distribute the 2?
Oh.
Okay.
You can rearrange.
If that minus 2, I mean the minus 1 had been a minus 2, you could rearrange in GCF. Or if that 2 wasn't there, you could do sine squared minus 1 and rearrange. But with the 2 there and then not having a 2, unfortunately we cannot. Go ahead, ask.
Wait. I don't know if it feels, and I don't know.
Go ahead and tell me. Go ahead and I can see your brain is still turning. So what are you thinking?
Oh, well, because I thought that, so if I rearranged it and put the 1, I thought you could just do the identity and then distribute the 2 on both.
It doesn't work that way. If you change sine squared, you can then distribute the 2.
Okay.
But you can't rearrange the 1 and then that 2 is still attached. Give me 1 second. Yes. Did you really? Okay. Yes.
Can you do double bubble? No.
Right now we can do double bubble. Why not?
Because there's nothing else.
There's a sine squared and that's a cosine x. So it's a handout. Yes.
You don't move the 1 minus cosine x first. And you like the sine squared x, you change it to 1 minus cosine x squared, and that's the difference in squared. And there's like 1 plus cosine x times 1 minus cosine x, and equals to 1 minus cosine x, and then you cancel out those 1 minus cosine x.
You're gonna have to write that down.
She got lost.
No, I see. Go ahead, bring it up. I see where you moved over, And you, I could stop you right there. It's not difference of two squares because of the 2 in the front. Same problem she was having. Okay, yes.
So we just change the sign square, right, and then distribute the 2.
Yes.
Yeah.
And then simplify.
Yes, is that what the other hands were going to say?
Yeah.
Okay, that is correct. So a few of you did say that. I'm not saying you were wrong, it's just more hands came up, so I was taking more suggestions. All right, everything is staying the same, except I'm going to change sine square to what? 1.
Minus cosine.
And then what am I going to do with that 2?
Distribute.
Distribute. What the heck?
It's just like 2 minus 2 cosine squared x plus
Okay, 2 minus 2 cosine squared x plus cosine x minus 1. The only like terms I have are the 2 and the negative 1. Cosine and cosine squared are not like terms.
Okay, so then you do.
Minus,
So it's like
then you can.
negative 2 cosine squared x plus
Yeah,
cosine
can't you
x
do that?
minus no plus.
1. Okay, so now go ahead. What were you guys going to say?
Yeah, the double bubble.
I do want a double bubble thing, but what's kind of in the way that I don't want?
The negative.
Okay, 2 choices. Divide it both sides by negative 1. If you divide both sides by negative 1, would it get rid of the negative 1 in the beginning?
Yes.
And 0 divided by negative 1 is still 0. That's the way I personally like to do it. Some kids will move everything to the other side. Add that, subtract that, get everything to the other side. Some kids will factor out a negative. It's up to you. Anyone have a preference on what would you guys do? What was that?
I would factor in the negative.
Factor out the negative? Most kids factor out the negative, and to me, that's the harder way, but that's just me. Cosine squared x minus cosine x minus 1 equals 0. Okay, if you those of you that would factor out the negative 1, what would you do with it? Just leave it there and factor?
Yeah.
Yeah? The rest of you guys, yes? You would leave it there and factor?
Yeah.
Okay. Now I went straight to factoring, and some of you might, but some of you also might be doing what? Instead of going straight to factoring, some of you might be doing what? U substitution. Negative parentheses 2u squared minus u minus 1. If you feel like, I don't need to anymore, then don't do it. All right, anybody have a factor 2u and u minus 1? Okay, set them all equal to 0. What does u equal? Negative 1/2. What does this u equal? And what happens to that negative sign in the front? It cancels out. Do we have to worry about that? Is a negative 1 by itself going to equal 0? No? Which is why I like to get rid of it, because many times when kids have that there, they try to do stuff with it and distribute back in, and it just makes a mess. Ignore it if you did factor it out. It doesn't do anything to the problem. All right, cosine equals negative 1/2. And cosine x equals 1. Cosine is negative in which 2 quadrants?
2 and
3rd. And what's my reference angle? Cosine of what angle is 1/2? Is it of 60? Okay, so 60 degrees in quadrant 2 and quadrant 3. So 180 minus 60, 180 plus 60, what do we get? 120 and 240, and then cosine, when is cosine positive 1? Is it okay if I use 360 instead of 0? No. If you look up here, it's, where is it at? It's somewhere equal to 0, but not equal to the 360. So 120, 240, and 0. Any questions?
No.
Make sense?